So I thought this was going to be would be a really interesting topic because it's a discussion I've seen on SCADASEC, on message boards, at other conferences, informal and formal, about this question: is the Purdue model dead? Are the things that you heard, let's say in the previous keynote, have they killed the Purdue model? And I'm not talking about it from a real strict interpretation. If we could put up the slides. From a real strict interpretation, I'll show you a couple of pictures. I mean, you have this very old picture from one of the original papers, and then you have a variety of other ones. But the thing that they have in common is the Purdue model is very hierarchical. It has levels from 0 up to 5, and it was at least originally envisioned to be a control system that would be separate from everything else. And this is the ISA version of that. So we've been hearing with the changes and things moving to the cloud and varieties of sensors being deployed all over that maybe this hierarchical model no longer works and we need to replace it. But I guess I'll start out, Brad, with the first question, straightforward. Is the Purdue model dead?
Well, from my perspective, when you start to talk about the strict architecture aspects of 95 and the Purdue model, I'm here to say that the model is dead. Also, I think that the model kind of died when we evolved towards Ethernet, so you could say that the Purdue model is dead and convergence killed it. So from that standpoint, from my perspective, I believe that the convergence that we're seeing is largely over in terms of technology. There isn't a business technology today that isn't used in industrial control systems. So with those two things in mind, I believe that the Purdue model is dead.
Just a quick question on that. What about the flip side? Is there a technology in the ICS or OT world that is not used in the enterprise?
That's a good question. Strictly speaking, from control systems themselves, the technologies there are used in the enterprise, right? But I think we're at a time right now in history where there's just technology. There's not IT or there's not OT. The business impacts and why you use those things is important. But in the end, there's just technology now.
Okay. Well, Joe, I'll let you get a crack at the big question. Is the Purdue model dead?
Well, I would definitely disagree. So if we take a look at, and again, I kind of don't consider the Purdue model as a single drawing, as Dale went through a few different examples. The Purdue reference architecture actually it's an assemblance of a lot of material associated with how we started to look at integrated manufacturing, when I kind of refer to it as the integration era, which pretty much started in the early 90s when organizations wanted to integrate all aspects of their business, from the manufacturing line, integrated with supply chain, integrated with all of the maintenance and procurement activities. So, though the architecture from a network perspective is probably dead because networks have significantly evolved, what I believe is still relevant to the Purdue model is effectively how all of these pieces are supposed to be layered and interoperate. Because if we lose sight of that, then we're going to lose sight of why we created hierarchy in the first point. My favorite drawing is actually one that refers to the different levels in terms of their time domain, where when you start at the sensor level, you typically are sub-second type time domain, and then as you move up into 3 and 4, you tend to move more into hours, shifts, and days. So I believe that it is still alive and well. And of course, we'll talk about why as we move forward.
Well, before I put up your model, Brad, obviously you disagree. So what in what Joel said is I guess not right, or you need to shade a different way?
I would say that he's right in terms of what specifically he said around the business aspects or the interoperational aspects. The 95 still has so much to add in terms of taxonomy and classification and how we talk about the elements of a control system. Those that's never going away. That's a very valid tool for that. But as we start to talk about your network layers, right, and where things are done and how things are done inside the control system, I think that the 95 model, the Purdue model, is somewhat of an archaic way to have a discussion around it, an infrastructure, a network. Networks are very important, as you said, but we're here talking about security, not just the availability aspect of this. And when you start to wrap security around levels, I don't know that that's the appropriate way to secure a control system. At that point, when you start to talk about those security boundaries and security layers, you start to put controls in between, potentially, in between PLCs and I/O, or HMIs and PLCs. And to me, that doesn't make a lot of sense. One of the things that I always say to my clients when I talk to them is we really need to strive for a very close one-to-one matching of industrial control system and mechanicals and the process itself, as well as the network, the application, and the security built throughout that entire process. If you can get to that model, that's how you build a secure system. It's different than bolting security onto the outside. It's inherent.
Did you want to comment on that, or should I move to the
yeah,
model?
see, because
I thought so.
Oh, of course. So it's really interesting to see how we've evolved the industrial automation and control arena, right? Because you're right, if you take a look at what the major vendors did in the 80s as they started to develop their base model architectures, as the Purdue model and 95 were coming out, you started to see them create this rigid alignment. Now, the thing is that what's happened is unfortunately we've got baggage, right? Baggage is always detrimental to progression in some aspects, because the vendors would then start creating justification in 2018 and 2019 for reference architectures that were developed over 30 years ago. So the idea now, and this is where sometimes I get, I've been better on Twitter, you guys should all notice. I've been really trying to behave.
Gentler, Joel.
But the idea is that people were trying to take the Purdue model and call it a security reference architecture. The Purdue model to me is basically an organization's informational structure, but it lacks any overlaying of risk, right? So security is all about risk identification, risk tolerance, and then finally the risk that you're left with, the residual risk. And that's why even if you look at the 62443 documents, the architectures that they draw are not security reference architectures. They're security ideas. Because we all know, Brad's ex-Rockwell, the exact same equipment can be used across enormous broad span industries. And the actual deployment of risk in each of those sectors, and when you overlay geographic region and so on and so forth, varies greatly. And that's why I think without the Purdue model, you fail to understand how all this flows organizationally. Because in theory, the Purdue model, and they did a pretty good job considering when it was written, still is very industry independent in how information flows throughout an organization, you know, and how we incorporate all this. And only when we start to look at that from a risk perspective, because one thing Brad and I think, both believe in is that it's not the system that we're trying to secure. It's what that system is supposed to be doing, whether it's generating electricity or controlling a turbine or refining oil. It's that we're trying to secure, which is why it's important that we use the Purdue model as kind of our basis for identifying potential attack vectors, potential attack targets, and then working to mitigate the overall data flow.
Well, why don't we, before we get too far along here, why don't we put up an example? This was a diagram that Brad created for maybe a potential future reference architecture.
Correct. So when we start talking about where we are today with 62443 and 95 and all the different models that we put out there, none of them really adequately define not only zones, but also take into consideration interaction with the cloud. IIoT is a real thing, whether we want to admit it as security professionals or not. It's almost irrelevant. Pandora's box was opened, and it was opened by the business, and we are now in a position where we have to really play catch up. To your point earlier this morning, we are in a position where we have to play catch up to do the things that are required to secure these systems. So instead of trying to fight and put close Pandora's box, right? We need to guide our business leaders into making better decisions and give them a way to do the things that they need to do, which starts to incorporate things like IIoT and connecting your industrial control systems to the cloud, whether you want to or not. It's happening already. We need to give them a mechanism to do that and to do that securely. So what we're talking about here is the concept of taking your standard network style of diagram for an industrial control system and introducing the concepts of the cloud. And this, for many purposes, right now, not a lot of vendors are doing control in the cloud, but again, if you look into the future, it's coming. So with that said, the architecture that we have here is essentially an enterprise cloud as well as an industrial cloud, and you share data in between those two entities with dedicated interfaces, allowing you to segment the enterprise from the control system in such a way that we essentially go back closer to the mythical air gap, right? Where we don't have that close coupling between the two. Why do we do that? The number one reason why I wanted to have the discussion around this style of architecture is it takes the human being out of the mix. When you look at all cybersecurity, what's the weakest link? It's us. It's humans. Always has been. So why are we, traditionally, in order to get data out of these systems, we had to have some level of interconnection. That exposes human beings to this really complex, orchestrated style of architecture. If we can remove human beings from that complex, orchestrated architecture, we remove variables. And when we remove those variables, mathematically, we become more secure. It allows us to clear out some of the challenges around managing and monitoring and things of that nature as it pertains to the maintenance and overall upkeep of a system.
Well, there's a lot to chew on there.
Yeah, a lot to unpack, right?
I would just say one thing as you kind of started it, and this was something that Patrick Miller said at the on-ramp that I saw his slides, it was really good when you talk about this is going to happen. His advice for communicating with executives, you know, when you're people in the security position is be prepared that the executives are going to accept much more risk than you want them to accept.
That's right.
That's almost a stated goal. So that kind of ties in. This is going to happen because unless the world is going to end, they are going to accept some of the risk of doing these things. And we need to come up with the right model to limit or manage that risk for them.
You're absolutely right, and Patrick's absolutely right. The best case scenario, though, is you're having those conversations with the enterprise and the executive leaders, and they're making the decision. The challenge today is we've got control systems engineers who are trying to do the right thing for the process, and they got a P card, and they can buy Amazon Web Services, and they can buy IoT devices, and they could do this themselves, and they could do it on a shoestring budget, which means you're never getting to the point of having, to your point, the risk conversation. It doesn't occur. And that's the challenge. We need, through governance, we need to have some level of capability to guide them to the appropriate way to do this, rather than just pretend that it doesn't exist, do things the way we've always done, and then the enterprise and controls engineer is going to go do what he or she needs to do for that system.
Okay, you've been patient.
Yeah, no, so the guy, I don't want to turn this into a panel on risk, but it really does all revolve around there because, first of all, I'm so glad that you said that we're removing people at the data extraction layer and not at the operator layer. I was going to go, oh my God, how are we going to pull that one off?
I'm the one who says that.
But the idea here is that, so the one thing, and when we sit and we have these discussions about how we're going to move things, in theory, you've got to look at the cloud is a very generic term. And in simple terms, let's put whether or not they're shared or they're private. Because this whole idea that the cloud can mitigate risk, actually we've calculated that it actually can increase risk. Because now when you send things to the cloud, you don't actually know who your next door neighbor is anymore. and how secure the environment is from a parallel attack within the infrastructure that could then impact you. So we could go a lot of different directions on that, but the one thing that really jumps out about that architecture is, to me, from a control systems architecture and design, the cloud I don't like shown at the top of architectures, because the cloud now is just affecting the location of the physical asset. It should have nothing to do with how that asset sits in the overall control hierarchy. You know, I/O will always be I/O, right? We're not going to run wires into the cloud. But the idea of putting inside the cloud advanced application infrastructure for doing, very broad scale optimization, or we put historians in the cloud, which vendors are already doing today. What we're effectively doing is we're not moving that particular component, if we use the Purdue terms, up to level 6. It's still at the same level in the control systems hierarchy. It's just that it's been physically moved to a different location. Because that's where we really got to be careful, is that just because we've moved the asset into some virtual off-premise environment doesn't mean that we should take any shortcuts in how we secure it.
I completely agree.
No way.
I completely agree, because that's what the model said, right? That architecture has the cloud top to bottom, and you move things into the cloud or out of the cloud based on where they need to live. So we're in alignment on this particular point.
Right.
Amazingly so.
It is.
Well, so one of the things, and I had some people submitted other diagrams as potential other models. And maybe it's just because we're so used to the Purdue model, but they just seem to be less helpful in determining how you're going to architect and secure your system, because the Purdue model, we're used to it, it's very hierarchical. You say, okay, things go up and down this one place, we put in perimeters here, this zone is more sensitive than that zone. Those drawings, I don't know, are we ever going to have a drawing in a future model that's going to be as helpful and as easy, or are we looking at something where there really isn't a model, that it's going to be different levels at different places throughout an architecture, and you're not, maybe it goes to industry, maybe there is a refinery model, and that's different than a paper company model or something like that. Do you see us actually, either one of you, see us getting to the point where we have a replacement for this model, or is it going to be many models?
I would say that the model will change as technology grows and evolves.
Universally, though, across?
This model will not go away if we keep, what you're really talking about is building something with a different set of Legos, right? At the end of the day, we have just the same set of Legos that we always have had. So that's why all of these things start to look the same, and because we have the same tech. When the technology evolves, when you start to see the convergence, and if I were to, again, look in my crystal ball, I would say within the next 5 to 10 years, you're going to see another round of convergence. The convergence of traditional mainline ICS style technology that's far more cloud enabled. And you're going to start to see more and more aspects of control shuttled up to the cloud style infrastructure. That's when we have a new set of Legos. That's when we can build a new diagram, a new set of pictures that can help everyone explain the pros and cons of a system type, for example.
Okay.
So this still would bring me back to the same premise, is that, and I'll just use a generic plant, so whether it's manufacturing or process. Again, I still would challenge that the model is still intact, because we still have pieces of equipment that have sensors, actuators, that are connected to controllers that are associated with the equipment, that are modeled around the plant, that are part of a larger facility, and that doesn't change. So the technology, so let's take the technology, since we'll just, I don't know, whatever date you want to call modern control, typically we tend to think of it around World War II era. It hasn't really changed. We went from air to wire, or air to point to networked, and on, and it's evolved, but the way that we build these facilities up hasn't changed. So where I think what Dale was saying is going to start to evolve are along the directions of, okay, so I'm ex-Honeywell, and what Honeywell developed when they started to see this transitional change because people architect control systems really inherently according to the Purdue model. They take I/O, they put it into work cells or process equipment that then is built out. But what Honeywell allowed you to do then was to have a soft modeling around it, where you could then group things not based on their physical architecture and physical location, but more on their operational integration. So when they created the enterprise model, it allowed you to group. You could have points from very separate parts of a plant combined together to represent a functional, operational entity, so that you could then do control, performance, alerting, and so on around that. So that's how I think it's going to evolve, but I think it's still going to, until we see the next generation of automation and control, which I don't see in the near future, I don't think it's going to change. Again, we're moving pieces geographically, which to me is just taking advantage of a different technological platform. It's not really impacting how we run a facility.
But I think one of the challenges we have, and it's always existed, but if we look at level 1, for example, we tended to view level 1 as a certain set of assets that we isolate and secure in a certain way, even though the criticality varies and we might, deploy more redundant systems, we might protect some more than another. But in the traditional, we see it as one layer with a certain level of protection. Now we're going to have some of these IIoT low-cost controllers out there that are going to have much less risk and require much less security controls that would be in the traditional model level 1, and then the very sensitive ones that you've dealt with your whole career inside refineries still. And we're even running into the case where level 1 is being split. So we actually ran into a case in a utility, not electric, but a different type of utility that had a virtualized controller that was separate from the I/O. So the controller function was actually running just on a virtual infrastructure on a bunch of servers. So you could actually have level 1 itself could be split up. How are we going to deal with each one of these levels going from being fairly uniform to being just a mishmash of all sorts of things?
So this is why I say it's dead. Because when I secure systems today, I don't secure level 1 as an entity. I secure a one-to-one mapping around industrial function. And if I can secure that industrial function in and of itself, not about the level at where it sits, but what it's supposed to do, that's hardened. That allows that device to function, or that thing to function appropriately. So it's not about securing the levels. You got to secure the function. And if you can secure the function, you not only do you win the battle, but you have a shot at winning the war.
That is so spot on. And that's one thing when Brad and I were kind of talking earlier, that's the one challenge that I see when I meet clients is their inability to actually understand, whether you call it the mission, in defense terms, the mission essential functions, the business entity's purpose for being there. And that becomes, it's not straight vertical and it's not straight horizontal. It tends to be, and you'll know the term, mission chains. When we actually calculate out mission chains and we figure out how a real actor would actually progress through an organizational architecture, not just the control system, but the organizational architecture that would combine people, facilities, and assets to cause their overall impact to our business. That's where I see is where the new evolving technologies are going to start to help, because we're going to be able to introduce a lot more concepts, software-defined networking. All of those will help us start to more properly secure the mission chain versus trying to secure a rack room that has a bunch of controllers and a bunch of I/O and some servers in it. That's not mission security, right? That's physical cybersecurity, if we could use such terms.
So the two of you agree on that, and at least one person in the audience agrees on that. But what is the impact on resources on achieving that? Because it's sure a lot easier to just say everything in this level we're going to protect this way. If you start to get down to functions, it kind of goes to how I started the event. I think we fail if we say oh, we're going to do it better, and it's going to require 10x more resources to do it. So what's the resource side of it?
So if we follow that style of thought in security of control systems, you demystify cybersecurity in this space. Why? Because you put it back into the framing of the control system engineers and their thought process in the model. So we're talking about the concept where a control systems engineer understands how this line works. So we secure the line as an entity, not the individual bits and components in it. Why do we do that? In the event of, say, a firewall failure, you want that line to still maintain operations rather than severing layer 2.
Oh, sure, I
right?
understand
So
that, but is that a lot more work? And is that like what Rob Lee said in his What If? Is this the case where the OT security guy knows as much or more about the process than the engineer? Or are you adding this burden onto the engineer? How does this actually happen?
So you start to get to that point where the IT or the OT security people are very in tune with the process. So the information flow goes both ways. It's a lot of work to do this out of the gate because you have to understand exactly where the control system functions will exist so that you can properly secure that functionality in and of itself. The problem is that, as you know, through factory acceptance tests and site acceptance tests, we never get to the point of doing a network acceptance test or an infrastructure acceptance test. Security acceptance test, whatever you want to call it. We go through the functionality, but we never actually look at the security built in and the infrastructure built in to support that industrial process. If we were to take it and move it in the proverbial left in the timeline, we have a shot at deploying secure solutions. Because right now, what we do is we just make it work. Nobody breathe. It's working. We have to get beyond that style of operations.
So there's one thing you said that I really think is the key to this success, and it took a while. But probably the biggest disappointment with me in the apparent convergence of S84 and S99 was they really didn't do much. It was more of just this, let's create a similar nomenclature around assurance levels, whether it's safety or security. But the idea that I wished we would have done as the S99 was being evolved was to start thinking like we do in S84. Everything is designed, tested, measured, audited around a safety function, not a safety system, a safety function, which consists of everything. It consists of the actuators, the sensors, the logic solvers. All aspects of this are put together in a function. And what that allowed us to do was like what Emerson Process did when they said, wow, we don't need to make these really big rack-mounted safety systems. We can take that idea and create very modular ones so that they could implement a very small subset of safety instrumented functions around a dedicated hardware platform. As soon as we start to move in that direction in the control side, I think we'll start to be able to do this step change that Brad talks about.
Well, we're running up to our end of the time, and I want to give you guys a chance for a last word. I guess what I'm taking from this conversation, which is actually very helpful to me, is the Purdue model I don't think is dead, but the diagrams we use are obsolete. And maybe its value in terms of determining security controls is much less. I mean, because it is what it is. You need these functions, and they do happen in a certain type of hierarchy. So I guess it's not quite dead. It's just not something we're going to be able to lean on, in my opinion, heavily in the future. And I just give you guys a chance for quick final thoughts.
I think you're spot on. The idea that 95 was dead or the Purdue model is dead really was based on the network aspect and how we build that. We don't build networks that way anymore. The bus technologies are gone, for the most part, for your mainline communications and ICS. So from that standpoint, it's dead. But from the taxonomy and the integration and all the things that you talked about from a business standpoint, agree, it's still alive and kicking. But I don't know if that's...
The value of that is questionable.
Yeah.
Joel?
No, I completely agree. From a network representation, I believe that aspect of the model is dead. I mean, I encourage you to read it. They talk about technologies like MAP The manufacturing automation protocol, I don't even think made it 10 years, right? It came and went quick. But the idea around how it can be used to consider security aspects, I think is going to be around, because it does provide a good organizational structure. And no matter what your business is, we all do have the same type of a business structure in how we use supply chain to bring in raw material. We have maintenance organizations, engineering organizations. We have products that we need to deliver. We have utilities that we need to consume. From that aspect, I think the Purdue model will be still a cornerstone document in understanding organizational risk as we secure control systems, which are a key part of it.